Today we're going to do some slicing and dicing of text and images. So before I go into it, just a word of warning or maybe a disclaimer. This is not quite like the After Effects shatter effect. I know a lot of people are looking for it, and from the introduction video it may look like it is like that, but it is not quite. And I just want to get it out of the way because I don't want to set incorrect expectations. So here you can see some of these After Effects shatter effect images. You can see it probably best here. You see all these irregular pieces and such, and that's basically what it does. It explodes the image into irregular pieces. Now with my effect, it's not quite like that. It looks like that though when you have a title. So for instance here, I'm here in Fusion 17, and there you go. They all look like irregular pieces, but they're not in fact. Right, and that's sort of the trick, I suppose. For instance, when you have a look here at the replace mode and set this to keep, then you sort of see what's going on. These are in fact all evenly sized pieces. It is just because there's transparency around the text and not everything is fully aligned that it looks like they are irregular pieces, and that's really how you can sell the effect. So I just wanted to get that out of the way. Having said that, let's dive right into this. And we're here now in Davinci Resolve. So we'll start with dragging in a Fusion composition. Make it a bit larger, and there we go. Now here on the Fusion tab, we'll start with a background node. Let's display that in viewport 1. Set the color to white, like so. And there we go. This will serve as an input to the P image emitter and then followed by a P render. Now let's pop the renderer in there, and there you can see our background represented as particles. You know, when you zoom in, you can see the individual particles. This is way too dense for our purposes. So in the P image emitter, we're going to alter the X density, 0.012, 0.012. There we go. Now, the other thing we want to do here on the rotation tab is untick the always face camera, because we will be rotating the particles later on. We also want to increase the lifespan a bit. And that's it. That's all we need to do here in the P image emitter. So how is this going to work? Well, we're going to replace these particles by image planes. Now, to do this, we use a replicate 3D node. If you would display this right now, you get an error message because it requires an input. So an image plane, in our case, an image plane. Pipe this in here, and then you get something incredibly large. Now, before we start altering that, let's work on the inputs here, and let's feed this with a little square, because I want my particles to be square. They don't need to be, but I kind of like it. All right, so on the image tab, let's untick alter resolution and set it to something like 50 by 50. There we go. And we'll pipe it in here, and there we go. This doesn't look quite right, because this is all a bit wonky. So let's work on this. So on the scale tab, if you scale down, there we go. Now we see what we're going to get. Right. So if you want to get this in the ballpark, in the right ballpark in terms of the scaling, what you can do is basically use a little formula. Basically, you need to use the image width and the density, multiply those, and do 1 over the result. So what you get then is basically 1 divided by, open brackets, 1920 times 0.012, close brackets, and there you see 0.043, and there you can see it almost lines up. So we could say maybe 3.5 or even 4.4. There you go. This is good enough, right? So now there are no gaps in between, and that's what we want, but we don't want to have overlap either. So you need to work on that a bit. Right, so now that we've got that, we need to actually do one more thing in this node. The alignment, set it to TBN aligned, because we want the rotation, which we'll see later on, of these image planes to be in alignment with the rotation of the particles. That makes sense, right? So the next thing we want to do is basically, okay, we want to have an image here, and let's start with a text example. So we'll take a text plus node, display that over here, and call that Blackbird called 2. Maybe I'm a bit too self-obsessed with my channel name here, but hey ho. Bit larger, this looks good. So how we're going to get this image onto this? Well, you can take a material, replace material 3D node, and then feed the text into the input here. And then what do we get? Well, that looks pretty cool, but it's not what we want, right? We want it only once. So what you can do to fix that is use a UV map node and display that. Well, it doesn't look quite good, right? So let's set the map mode that's planar is actually good, but the orientation, we want that facing it on the Z-axis. Now you only see one word because it's not fitting quite right. And what we need to do is basically just hit a button. That's it. And now it fits. Great. Right. Now there's one more very, very important thing, right? And that is to tick this box, lock UVs on animated objects. When you do this, you can see that you can select a reference time. That is by default set to 0. And what this means really is that Fusion will use this time to project the image, or in this case the text, onto the geometry, the 3D geometry, our particles or our image planes, at that point in time when they're at that position. So in this particular case, all the particles are together, so it projects it at that point. Now, if for instance you would do it the other way around and you fly in particles from a state of chaos, if you will, to the final state, and if, say the final state is at frame 60, you want to set the reference time to something like frame 60 or later, because then all the particles are together and the image projection should really be based on that position. Now we've done that, right? Let's illustrate it actually. So we add a P turbulence here. So when you play this, you see it sticks nicely to it. If we would not have set this, sorry, in the UV map, don't lock it, right? When you play it, you can see it doesn't stick to it. So it's very, very important. Let's get rid of the P turbulence and let's work on the animation, right? That's the other thing I want to get into. So P custom, that's what we're going to use. I love myself a bit of P custom action. We drag it in here and we go head into the particle tab. What can we do here, right? Let's start with something really simple. So when you use an image emitter, the Z position of the particles will always be at 0 unless you change the position of the region. If we want to animate that, we can easily do so. But let's first, set a random position for each particle, a random Z position. We can do that by rand S, so random position based on a seed. Minimum value, let's set it to -2, 2, and then the seed, that's based just on the particle ID. And there you go, boom, we're there. How do we animate this? Well, imagine we use a variable n1 times this. Now, n1 refers to the number step, the very first variable number in 1. So if we now increase this, right, we see this happening. And that's really cool, and that's really what we want. If we now animate this number 1, on frame 0, we'll set it to 1, and add a keyframe, and then at frame 60, we set it to 0. Right? So now we can actually play this, and we see it's getting together. Now, I do want to already, on the UV map, set the reference time to something like 60, because or 70 even, because later on we'll start rotating the particles and such, and if we then wouldn't have had our reference time set, it would look all weird. So that's fixed now. All right, so rotation, right? We want these particles to rotate as well. So we can use the exact same technique with that N1 we've now got animated, right? So let's go to the rotation and let's work on the X rotation. So again, we can set a random position, say between -360 and 360. Oh, and a particle ID, a seed. And we'll make that seed based on the particle ID again, but a bit different to the other one. Otherwise, the seed will be the same and the random values will be in complete alignment. And I don't like that. So I do it ×2, close brackets. Right, so now we've got this random position. So if you now animate it, so all our rotations are intact, but at the end we want the rotation to be 0. So we do the same thing. We do n1 times. Right, and if we then play it, we see the rotation happening. Bang. Awesome. Right, and if you want it to rotate faster and such, right, you can increase these values, right, at minus 360 and 360. Now we can work on other rotations as well. You can put a similar formula in rotation Y and Z or not, right? It depends on what you like. But when you do that, I would advise you to use a different seed value, right? So instead of here ID times 2, maybe make it ID times 4 or 3. Right? As long as it's not the same, because then again it is in complete alignment and it can look a bit odd, or it can look great depending on what you're after. Right, so now we've got this. Now in my examples we also animated the X and Y position, but that's a bit more tricky, right? Because with the Z position, actually everything went back to 0. That's the base position. But for the X and Y, depending on the particle, it could be different, right? Somewhere like here, that would be, position maybe 0.5, whatever, 0.25. So somehow we need to animate that. And how do we do that? We can work with a random position, of course, but how does Fusion know what value to get back to, right? So if we make a random value here, rand as minus 2,2, ID times, let's say 7, whatever. Now that's an interesting one. You can't actually see what's happening here because we haven't animated this yet, and then the UV mapping is a bit wonky. So for now, let's display the replicate 3D instead of the UV map. Here we see all the particles, right? We see the X spread. We want to do something similar for Y. So and then copy it and copy it here and make this a different seed times 8. Right, and now we've got this spread all nicely spread around randomly. So, but how do we animate these, right? We can't do N1 just that, right? Because it would all go down to 0 and then you've got your straight line. That's not what we want. We want to go back to what it was, right? The original X position. So what we are going to do is we're going to make use of these two variables, mass and user. Mass is really not used internally, neither is user. So we can just use these for our own purposes to store values. So what we can do is basically at the start of the lifetime of a particle, store the X position into this variable. So the way we do that is if, open bracket, H equals 0 at the start of when it's just emitted, then store the X value, px, otherwise, comma, keep mass, right? That basically it stays the same after that. We do something similar for the Y position, for the user parameter or variable, if H equals 0, comma, py, comma, user. Now we've got that stored. And now we can use that here. Right, so we can say, okay, N1 times this. So that means here at the start, we've got this at 1. So it takes this full value. But if we then do plus 1 minus N1 times mass, then we're basically saying as N1 is decreasing, right, when it starts at 1, so it is plus 1 minus 1 times mass. So it's cancelled out. But at the end, it is 1 minus 0. Then it means 1 times mass, and then you've got your original position. I hope that makes sense. So let's give that a go. There you go. It may be a bit hard to see, but let's do the other one. Right, first the Y position as well. So we do N1 times this plus 1 minus N1 times user. And when we now play it, it goes back to the original position. How cool is that? Right? And here, for illustration purposes, if we would have set the reference time to 0, you get something really weird. Right? And that's what I meant. You got to be very careful here that you set the reference time correctly. Right? So say 60 or 70. Now we play it again. And there we go. Looks great. Now you can play around with the interpolation and such. You can ease the motion. So just go to your number in 1. Right? And you see it here. Let's zoom out a bit. Select these 2 points and select easing. Right? And now you've got a bit of easing action going on. And then you can play with it as you want. And you can even add points here and move them around. You can do some crazy stuff. Right, this will probably look a bit odd. Hold on. Right, but play around with it. So I'll just undo that for now. So that's looking pretty cool. All right, so we created our animation. So let's now render it out. So we are going to add a merge 3D so that we can add our camera in. All right, like so. Let's pipe it in here. There we go. Display it. And we already see the camera view here. So let's work on that. Well, it's not an awful lot to do. Really, we'll zoom it out a bit. Maybe something like this. Maybe a bit more. Let's play this. Okay, well, that is not quite enough. There we go. Maybe something like this. Now, if you, sometimes you'll see that the camera is not completely aligned. Maybe that's the case here because of the rounding of the particles. It has to do basically with the X density. It will round it down to the nearest particle. So sometimes you may need to sort of move it a bit to the right or left, whatever, to line it up properly if you want to have it centered. Right, but let's leave that for now. So the next thing we want to do then is add in a renderer 3D. Let's display that. And let's set it to OpenGL. And in this particular case, I'm not going to add any lighting. Of course, you could do that. And in some of my examples, I did. But for now, I'm leaving this. So transparency, I'll set to accurate. And then I want to add some accumulation effects, i.e. the depth of field. It will take a bit. And of course, this is all wrong. Now what's happening? Our focal plane, and I'll show that here. On the controls tab, control visibility, tick the focal plane box. And there you can see it's focusing way behind the text. So we would need to fix that by moving this in this direction. Now it's a bit slow right now because I'm displaying the renderer. So just want to get rid of that. Here you can see, okay, now it is in focus. Now, quick tip. If you want to be extremely accurate, expression, and then pick whip the Z position. There you go, now it's spot on. All right, so back to the renderer 3D. We can see that everything is in focus and a bit earlier on. Right, you can see a lot of it is completely out of focus. Now, first of all, I think that's a bit too much. I really want to dial down a lot to something like 0.02 because I used that in my example before. All right, so that looks good. Of course, for the final render, you would want to up the quality here. So you can, for instance, set it to 128. Takes a bit longer to render, but once you're happy with the animation and everything, it will make a real difference in the final result. For now, I'm just dialing it back down to 32 just for the purposes of this tutorial to keep it somewhat snappy. The next thing I want to do is add a bit of motion blur. Now, you could add motion blur here, but I find this to be pretty slow, especially with a lot of particles involved. So what I typically do instead is basically go to the output channels and add in the vector. So now the renderer will also output vector channels. And then we are going to add the vector motion blur and display that. And you saw a tiny difference here, Ctrl P to bypass, right? You see that hopefully, I don't know if it comes through on YouTube, but it does make a difference. But of course you can make it a lot more extreme, like you see over here. Now, you got to be very careful, especially with fast moving particles. It can start looking really quite extreme, like this is way too extreme, unless you want to go for that type of effect. So just be mindful of it. All right, so that looks pretty good. So you can now render it out and then you're done. Or you can do all kinds of stuff, of course. You can add some glow. You can make it all look great. You can also work, of course, on the P custom and add some more rotation, as said. An awful lot you can do. Now, I said at the start we're going to slice text and pictures. To be honest, all you would do here is, instead of adding in a text, add a type of picture into this, right? And then you're done. The only thing you need to take into account is the aspect ratio. If your picture, your final picture, has anything other than sort of a standard HD type ratio, you also need to ensure that your background here has got that same ratio. So they ideally will really need to match. If not, it's not the end of the world, but then it can look a bit stretched out or squeezed or whatever. Now, before I end this tutorial, I'm going to show you the template I mentioned at the start. And again, this is available on my Patreon website, and you can become a patron for as little as $1 per month or $5 per month. So let's go to the templates. Let's show this here, right? This is by default what it does. Right, that is looking pretty cool. Right, it has got quite a few things. First of all, the camera motion, it's in the transform. It's a very basic one. I can just disable that for now. And then we just have a frontal view. Right, and what you notice here is that not all particles arrive at the same time. Right, and that is something you can easily set in this template. Right, you don't need to faff about and work it out yourself. You can just do it here. So you do that in the P custom. So first of all, the animation, as with the example we just went through, is done via the N1. So you can change that in the spline tool or whatever. You can do it completely different. The minimum rotations really refers to what is the minimum rotation speed of a particle in case you have one or more of the rotations enabled. It is a bit more complex than that and the way it works underneath the hood, but just sort of keep that as a rule of thumb. The maximum, well, that's the maximum number of rotations. So if you want to have faster spinning particles, just up the maximum, up the minimum. Or if you want to have more sort of variation, have a low minimum and a high maximum. The spread basically says, okay, how far do I want my particles to be spread around at the start? And the jitter, that is what I was just talking about. That is, if it is set to 0, it means all particles will arrive at the same time. You can see that happening here. Bang. Now that may be the look you want to go for, but if you want to have that slow build up, have a jitter higher than 0. In my case, I had it at 0.8 because I thought it looked good. Right, so that is basically how this works. Of course, you can change your text here. You can change a lot about it, right? You can change the shading as well. You can add some outline to the text and such, you know, play around with it. But I'll just quickly show you how it works if you would input a picture, right? And let's switch this to perspective for a moment. And if you play it here, right, then you've got this picture being built up. Now, if you think I want to have some more rotations, right, it's now only rotating via the Z-axis. Enable the other ones as well. And then you see more of this rotational stuff going on. Pretty cool, right? If you also want to sort of say, okay, I want to change the easing, right? You can go to the spline and you can go to the N1 movement, show that. Oops, zoom out a bit. Right, and then you can work on this. You can let it come in a lot slower. So if we do this now, you see it really slowing down at the end. Right, so that is the way the template works. Now, there are a few other things happening. For instance, this whole business around scaling, that is automated. And there's a fine-tune parameter. If the scaling is not spot on, as we saw in the example earlier on, you can just fine-tune it here. Now let me show you one more cool thing about this template. It has got a lot of flexibility pertaining the ratio of the input. Right, when I say that, it is maybe easiest to illustrate with an example. So I'm just going back to the start of the animation, and let me just show you maybe just to replicate 3D. All right, so let's zoom out a bit here and say for argument's sake you want to have a portrait type ratio. So let's make it 1080 by 1920. Right, you can already see things are updating automatically, but if we then also, you know, input maybe the text instead of the image, right? And let's make the text also 1080, oops, by 1920, right? So if we now play this, right, that is all working, but let's actually show the image or the text. And let's zoom in a bit. You see this squeezing here. And what we need to do is basically fit this again, the UV map. And when we do that, bang, it's all done. So now we've got a different aspect ratio. It doesn't really matter with the text. But, you know, imagine using an image. You can use a totally different image with a different aspect ratio and it will just work. You just need to ensure that you hit the UV map fit button again. And of course, as I said at the start, the reference time is always very important to keep an eye on. All right, maybe one more thing. In the renderer 3D, by default, the lighting is on with a bunch of lights here. You can, of course, switch it off should you wish to. And I think that was all there is to it. If you do have any questions, let me know. See you guys next time. Take good care of yourself. Bye-bye.